Then I don't know.
Not use 10, you only use 10 when you're. I'm confused about friction.
Okay, I'll be right there. What's up?
Like in this one,
Yeah.
the balance in the like elevator thing.
Let's see, is this
Why are
one?
you using 10 and not 9?
Because it's
It goes
all
down
relative.
to his.
Just like
It's just direction. What's confusing about friction?
I'm just like finding it.
Hey, if it says constant velocity for letter C, right?
Yeah.
Is constant velocity mean balanced or imbalanced? All right, so it's balanced. How much left force do you need to balance out 80 to the right?
Oh.
How much left force do you need total to balance out 80?
Very small.
How much total? 80.
And how much is your friend giving?
30.
How much does friction have to be? Okay.
French length doesn't just. I should be like, what do you?
Am I on right now?
No, I was.
We do presentations of like a.
What question?
What do you want, Mr. Duckman?
I'm on light.
Not like.
I was about to say I'm on Julia, but that sounds really horrible. So
He's on the purple pill.
that's a little embarrassing. My apologies. I'm on cat drugs.
You're on recording too.
That's great. No, it's not cat drugs. It's Nisha Patel. Social Security number 000000001.
Okay.
He's also wearing a really weird blue hat.
Dude, when I finish the physics final, I'm gonna stamp $100 bill.
Excellent.
So,
That'll buy you nothing.
We're crying. I need a beat.
This recording is happening on May 28th, I believe. So there's your confession.
Look at $100 bill.
You need a B for what? To get a B?
To get an A. I'm trying to A gang up here, bro.
All right, we're about to cover the last two kind of ideas from today. That are pulleys and ramps. Special force situations. Looking up here, I'm going to draw both cases.
You okay, Edie? No. Okay.
Now, the first thing you might remember with ramps, Julia and Edie in particular, normally we have weight going straight down, which is good. But in this case, weight going straight down doesn't help us out. Because this thing's either move uphill or downhill. I taught you about weight X and weight Y. Can your partners in the next 45 seconds please try to determine which one of these was weight sine theta and which one was weight cosine theta? Please come to an agreement or at least a civil discussion.
No, that's cosine. How do you figure that out? Because the x.
I taught you a way, but it's really tough.
Are
Which one of these is weight sine theta? Which one is weight cosine theta?
right. And I don't remember. Because it's opposite height, like opposite.
In case you forgot, weight X is weight sine theta, and weight Y is weight cosine theta. Now, please take out your forced finger. And please now point it in the direction of the normal force on this object. Look to your partners who will help. Which way is the normal force on this box going to be? Will it be straight up? Will it be to the side? Will it be straight down? And it turns out it's always perpendicular to the surface, which would be this way. So what is the normal force balanced with on a ramp?
The weight line.
Weight Y. Not just the weight, but just part of the weight. Cool so far? Okay. Let's say a box is on a ramp and it's going downhill. Can you please quickly figure out which way the friction is going to be in this case?
Opposite way, it's gonna be pushing.
Which way would the friction be in this case? Anybody feel comfortable telling me which way it's going to be and why it's going to be uphill?
Because it's always opposite.
It's always opposite the motion, okay? Let's draw friction here. But this box is not moving uphill. Why is it kind of moving downhill?
Gravity's too.
Part of gravity is pulling it down, and the thing that's pulling it down is weight in the
Y or
X.
X.
And from here you could probably make a net force equation. These two are balanced, these two are unbalanced. You're going to try an example of this in a little bit. It's not that bad, actually. For example, let's say you did the math and this was 30 and this is 20. How much would the imbalance be? 10 which way? Downhill. And you can find the acceleration from that. But then there was also pulleys.
Hold on.
Let's say 3 and 1. If I asked you to draw the forces here, yeah, there'd be two tensions up. But these two tensions kind of cancel each other out. Cool with that? But then there's also weights down. With your partners, please figure out how much imbalance is here. Is it 30, 10, 40, or 20? How much imbalance is there? 30, 10, 20, or 40? How much imbalance is there? 30, 10, 20, or 40? How much imbalance is there? Discuss.
It's 30.
200.
Why would me saying 40 be wrong? Raise your hand if you can tell me why saying an imbalance of 40 is wrong. I'm saying they're both down. Two down forces add up, right? But not in this case.
Because one is up here, so it ends up pulling the other one down.
Are they working with or against each other?
Yes.
Perfect. So how much imbalance would there be here? 20. Okay.
Counter.
And that equals MA. Of course. So which mass do I use? Do I use 3, 1, 4, or 2? Discuss one last time. Which mass do I use for the F? Is it 3, 1, 2, or 4?
Because the system thing.
Yeah.
4, because it's always system mass.
Yeah.
Now, if I was just looking at this picture right here, which mass would I use? 3. Because I'm looking at just one part of it. So as you can see, now you would not use the imbalance of 20 because the imbalance is on both of these things. You would not use 30 as your imbalance. You would do 30 minus tension equals 3A, and you would find the acceleration from this because these both have the same accelerations. You're going to kind of see this. I kind of drew it out for you a little bit, question by question. Can you please try a couple of these ramp and pulley? The last one's a ramp and